Time for homework help. Yep. Welcome, guys. It's time for some homework help. And I believe this is the last night of the week. So let's get started and finish it off, shall we? You should be on page 174. Don't confuse yourself. I really only want you to do page 174. 175, I believe, right after this, I want to save till a little bit later, if you don't mind. So here we go. 174, number 1. A choir concert lasts for 5/6 of an hour. The choir performed 3 concerts over the weekend. Let me circle that 3. Find the number of hours the choir spent performing over the weekend. The answer is between which 2 whole numbers? So like we practiced last night, it's not enough to get that first improper fraction answer. You have to get the best answer. And I'll show you how to do that right now. First, take your fraction. Then take the whole number that you see also in the word problem. And do some simple multiplication. Multiply straight across. 5 times 3. Excuse me, sorry. 5 times 3 is 15. 15 what though? Don't forget the denominator. 15 over 6. Now that you have 15 over 6, you might think, hooray for me! I multiplied the fraction, I'm all done. But there's a better answer. There's a better answer, and it will help you get the right answer here. You want to take the denominator of your first little baby answer, and you want to say, okay, I can make a fraction model with 6 pieces. That's pretty easy. 1, 2, line in the middle. That'll give us 6. And we're going to need, it's always a pretty good idea to make 4 of them. Why? It just seems like it's the magic. Oops, I messed it up. That's 9. Sorry. It just seems like it's the magic number to make 4 fraction models. 1, 2, boom. There we go. 1, 2, there you go. And 1, 2, boom. There we go. And that gives us 6 pieces per fraction model, which is what the denominator right there is telling us to do. Now we have to shade in 15 of those pieces. So here we go. Get ready to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Didn't need the 4th one. That's fine. We didn't need them. That's fine. And now let's look at what we have here. Now that we've made these fraction model drawings. We have 1 whole, and over here it looks like we have 3 out of, how many was it again? 6. And so we want to add all that up. You want to add up the 1, and the 3, 6. 1 plus 1 is 2, with the 3, 6 attached. Now with this new answer, I'm going to circle it in red. With this new answer, it's very easy to see what we should be between, like the problem asks. Between. Is it between 0 and 1? No, because 2 is bigger than 1. Is it between 1 and 2? Nope, it's a little bit bigger because of the 3/6. Is it between 2 and 3? Yes, indeed it is. The answer is C. Tell whether each equation is true or false, all right? So this is like 4 different problems in one, so here we go. 3 times 4 is 12 over 6. And you might go, oh, but they put 2. 12 over 6 is not 2, so this has to be false. Wait. Before you do that, try finding the best answer first. Remember, the best answer will have you drawing a little bit. So go ahead and draw. Fraction model with 6 pieces. Why 6 pieces? Because it says so right there in that little denominator that we made. So 6 pieces. And how much gets shaded? 12 of them. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait a second. What do we have here? That's 1 whole and that's 1 whole. Both of them together are 1 plus 1, 2. 2 is a correct answer. But you wouldn't have known that if all you had was 12/6. You have to see past that. Maybe you have to draw to see past that and find the best answer. A is actually true. B, 2 times 4 is 8, yes. And, oh, but look what they did. They did 2 times 5 equals 10. But you should know by now that they should have just done 2 times 4 is 8 and just kept the 5. Just keep the 5. Don't also multiply the denominator. Leave the 5 alone. So 8/10, they didn't leave the 5 alone. So that's false. How about right over here? 5 times 2/9 equals 5 and 2/9. No, that would be only if you were adding them together. But that's multiplication, not addition. So false again, I'm afraid. How about over here? 2 and 3/7 equals, no, 2 times 3/7 equals 6 times 1/7. Let's find out. 2 times 3 is 6 with the 7th on the bottom. 6 times 1 is 6 with the 7th on the bottom. Are those equal to each other? Is 6/7 the same thing as 6/7? Sure is. So there you go. True, false, false, true. But it's not enough to just, check the boxes. You have to understand how you got the answer. Last one for tonight, I think. Yes, indeed. All right, last one for tonight. Melanie wrote an expression that has a value of 15/4. Choose yes or no to tell whether each expression has a value of 15/4. So we just need A, B, and C to equal 15/4. If it does, then we check yes. And if it doesn't, then we'll check no. Let's look at the first one. 5 times 3 is 15. You keep the denominator, 15/4. Yeah, wonderful. 1 times 5 is 5. And that's is 5/4 the same thing as 15/4? No. 15 times 1 is 15, and you have to keep it to the denominator. Got to keep it over 4. Oh, that one worked out too. So that one was pretty simple. The only way you could have got that wrong is if for some reason you didn't multiply as usual, as normal. I mean, if you know your times tables and you remember to keep the same denominator, that's the bottom number of the fraction, then you'll be just fine. That's all the homework we have for tonight, guys. Do not do number 4 and 5. That is in the book also. I want to save that for a little bit later, if you don't mind. Though if you do it on your own and you do it correctly, good for you. I'll be proud of you. Good job, kiddo. All right, I'll see you guys next time. Have a good night. Thanks for doing your homework with me. Bye.